Okay, very quickly we're going to review a little bit about R here before we get into data mining with R. So one of the most powerful aspects of the R language is the vectorization of several of its available functions. These functions operate directly on each element of a vector. For instance, if we look here, we have a vector. We create the vector, and then we can do the square root of the entire vector v, like that. We'll call this vectorization. So that vectorization leads the function to produce a vector of the same length with each element resulting from applying the function to the respective element of the original vector. Okay, let's review quickly about factors. Factors are kind of useful for nominal data or categorical data. And factors have levels, which are just the set of possible values for the factor. So let's see what that means. So here we create a vector, and it consists of these characters, but you'll notice that some of them repeat. Now currently this is just a vector, and if you type in G, you get the vector back. But if you want R to, sometimes you want R to think of this a little differently. You want it to kind of recognize that there are repeats in it, and that this is more like a categorical variable that has certain set of levels, which in this case would be what, F and M. In that case, you want to actually transform it into a factor. And you can do that just like saying factor of G, and replace G with that. And now when you find out what G is, this indicates that it's different than it was before. It's not treating them as characters, for instance, and it also recognizes two different possible values, the levels. Actually, internally, factors are represented as numeric vectors, but we won't really worry about that, except just to check. If we do mode of G, it's numeric, whereas before, let's go back to before. Let's rename G here. Now it's character. I'll reset it as a mode now. I'm sorry, as a factor now. And continue. Now suppose that you have 5 individuals and their gender is all male, and you want to create a vector. The thing is, if you want this to be a factor, you want to have also the level of female there, even though it's not represented in your particular data set. So you're going to have to do something extra, because R won't recognize that there's an additional level without you telling it somehow. So you can do something like this. Let's create another G, call it other.g. Remember, dot notation in R has no particular meaning. It's not like an object like we think of in Java or some other languages. So it's just this is just the name of something. Okay, so anyway, we have a factor which is all males, but we tell it that furthermore the actual levels are F and G. So now if I type other G, I see that I do have only males, but it knows that there's actually another level in there, female as well. One other thing that we can mention here is that in mathematics we have something called function composition. That is, when we take, we have two functions, f and g, and we write f of g of x, like here. And this is an example of that, actually, right? Because we have factor on the outside, and then composition of that with the concatenation function as well. Okay, this is just an example of what we might call in mathematics function composition, like f of g of x. If that confuses you, don't worry about it, but if it doesn't, it might be helpful. But what we're doing is, in effect, we're applying one function, the factor function, to the result of the concatenation function. Now, one thing we might like to do with this other g, or with g, is to count how many of each f, how many f's and how many m's there are. In other words, how many of each of the elements in the levels there are in our factor. And you can do that with this function, table for g. So we can see that there are 5 and 5. However, if we did it with the other one, if we did it with the other g, we're going to get 0 for the number of males. For the number of females. Now, suppose that along with g, which has the gender of 10 individuals, we also had another vector which gave the age of 10 individuals, of the same 10 individuals. And we might like to see, like, for example, well, when I say the age, let's say we just indicate whether they're adult or juvenile. So here we have another a vector A, and it has exactly 10 entries. So we're talking about like the same set of individuals, but the first one was whatever it was, female, and it's an adult. She's an adult. And the next one was male, and he's an adult, and so on. And then we might like to know, okay, well, how many of the females are adults, and how many of the males are adults? So this is called how many of the juveniles are, how many of the females are juvenile, how many of the males are juvenile. This is called cross-tabulation of several factors. So we can do that with that. And this is going to produce a table, and it's going to have 2 columns and 2 rows. And the columns are going to be male and female, or female and male, and the rows are going to be adult and juvenile, like this. Okay, so here we can see that there are 4 adult females and 2 adult males. There's 1 juvenile female, and so on. By the way, one other thing that might happen when you're playing with R is you might have something like this. Let me just copy this part here. Copy it. And then let me remove it. So if I just hit that, and then by mistake or whatever I hit enter, then it says you haven't finished typing the line, and you have to end the syntax of the line properly. So I have to have, now I have a comma here, so it's going to be expecting at least another entry, and then 2 more closed brackets. So I'll just paste back in what I had. Actually, I put in 2 more entries, and then 2 more closed brackets. So just so that you don't get caught with that plus sign. Okay, some more stuff we can do. Suppose we want to know, I want to add these 2 and add these 2. So I want to know the total number of adults and the total number of juveniles. So 4 plus 2, there are 6 adults, and there's 1 plus 3, there's 4 juveniles. And suppose I also want to know the total number of females, so that's 4 plus 1, that's down here, that would be 5, and 2 plus 3 down here would be 5. So these calculations appear in the margin. So these are called marginal calculations, or marginal frequencies. So let me assign the result of the table to the variable t, and then I might write margin table t, comma 1, and that's going to give me the rows. So that's going to give me how many adults and how many juveniles. If I had put 2 here, it's going to give me the columns. How many are in how many females and how many males. Okay, so let's do that like that. And if we did like that. Now, suppose that you wanted to know the percentage of, so this is 4 out of how many, in other words. There's how many here? 5, and 5 is 10, so this is 4 out of 20. This is 2 out of 20, this is 1 out of 20, this is 3 out of 20. Suppose you wanted those results. You would do this one. So instead of margin table, it's prop or proportions. We get that. You can also find, suppose you want to know, from the adults, what proportion are female, and from the adults, what proportion are male. That's different than here. This is from all of them, what proportion are adult and female. So in probability, this would kind of be the conditional probability. Given that you're adult, what's the probability that you're female? What's the probability that you're male? That is given that you're an adult. So the way you would do that is with this command here. Now this is the 1 is the same kind of the reason we had 1 up here. We're going for the rows. So per adult, per juvenile. So let's see what that gives us. So the percentage, where's the number? Where's the original table? So from the adults, given that you're an adult, what percent are female? 4 out of 6, that's 60, that's 66, whatever, this number. And this is 1/3, which is this number. And the same thing here. Now we could also change that to a 2. And what's this going to tell us? What's this going to tell you? It's going to tell you that given that you're female, so let's go back to the table again. Given that you're female, what's the chance that it's an adult? What's the chance that it's a juvenile? So this should be 80% and 20%. And given that you're male, so this should be 40%. Well, 2 out of 5 is 40%, and 3 out of 5 is 60%. So we should get that, like that. So you can do those as well. Now, if you wanted to get percentages here, instead of fractions, you could just take this and multiply times 100, and you'd get percentages instead of fractions. Okay, let's quickly talk about generating a sequence. So we know about this one. It generates a sequence from 1 to 1,000. And this goes backwards. I'm sorry, this one is 10 to, rather, no. We have to be careful with the precedence here. This is kind of tricky, actually. This would be, this goes first. So this operator, the full colon, has precedence over this. So if this goes first, it means this generates a sequence of numbers from 10 to 15. And then we're subtracting 1 from each of those. So we get like that. So quite tricky. This one, fairly straightforward. And if you want to generate a sequence of real numbers, you can do this. So this means it's going to have a step of a half. Like that. From -4 to 1. And they also wrote a function like this. sequence like that. So if you change the length, you get that. And they also have a by argument or parameter. So you can do this, and it increments by. That's actually what I thought that -1 was before, but I mistook it. Now one thing to note here is that here, if you specify parameters, it assumes that this one has a particular meaning. So it's actually the by parameter here, right? It's acting the same way as the by parameter was here. So if you want to change a particular parameter and you don't want to specify these in order like this, you can use the names like this. So for example, I could put the by 0.2 over here. It doesn't matter as long as I say that it's the by parameter that I'm setting. Again, it's always good to review. What's this one do? It repeats the 5 10 times. We can also do this one. And they've also written the repeat function like this. So you can repeat actually that sequence. And they've tried to even be more clever or give you more options. And this one, well, instead of doing, is a little different than this one, as you can see, and is a different meaning. It's that. So probably it's hard to remember all these. Now this is for generating sequences, but these are just vectors. We did talk about something, a kind of a specialized vector in a way, called a factor. And if you want to generate sequences of factors, you have to use some different function. So this one, GL 3, 5. This one's a little bit strange. It doesn't. The results are not going to really seem like a factor. But we do know that it is a factor because it says levels. So it's kind of a weird one. The levels are 1, 2, and 3. So it generated 3 different levels and 5 of each of them. Kind of a strange function. That one doesn't really make much sense in terms of where or how you would use it. This one makes a little bit more sense. So it says there's 2 levels. We're going to have 5 of each. And the labels for the levels are not just going to be numbers like 1 and 2, but they're going to be female and male. So it's 5 female and then 5 male, and it says there are 2 levels here. Seems more likely that we'd want to generate sequences of numbers than a sequence of factors like this, but maybe there'd be some use for this. Now a little bit more of generating kind of sequences of numbers. We can generate we can use like normal distribution and so on to generate kind of random numbers. So here, this is going to generate 10 random numbers that are going to be normally from a normal distribution, like that. And these are going to be centered around 0 with a standard deviation of 1. So if you wanted to play with that a little bit, you could do this, generate 4 numbers sent from a normal distribution where the mean is 10 and the standard deviation is 3. So you get these numbers, which some of them are like more than 3 from 10 and more than 3 above 10 and so on. If you want to generate random numbers from a so-called student t distribution, you can use something like this. This is a student t distribution. There's different degrees of freedom, so you can have df equal to 1, df equal to 2, 3, 4, 5, whatever. So here we're specifying the curve that's df equal to 10, and we're going to get 5 numbers. And again, it's centered around 0. Okay, now let's talk about subsetting in R. Subsetting in R. So we've already seen examples of how to get one element of a vector by indicating its position inside square brackets. But R also allows us to use vectors within the brackets. Let's look at, we already looked at R norm 10. That gave us 10 numbers. Now I'm just putting it in a variable x. And now, if I do this, well, maybe I should do this first to see it. Okay, these are the vectors. Can't see them all. Okay, we can't see them all, but there's 10 of them. And the last few are what? Are out here. Now if we just want to isolate like this one and this one and this one or something like that, we can do that. Okay, so this is we're getting that this is a vector consisting of 9, 6, 7, and those are the ones that we're getting. Okay, this is not so surprising. However, let's look at some more interesting examples. So what is this? X is the vector we just talked about. Some of them are negative and some are positive, and we're saying x greater than 0. So what does that mean? Well, it just checks each one and says, is it greater than 0? Each one of the elements in x, is it greater than 0 or not? And it just gives a report back as a vector, therefore. And it's called a logical vector because it's true, false. Those are called logical values, so it's called a logical vector. So what is this going to do? So now again we're putting, well, again we have x out here, and then we're putting in, well, we just saw what this was. This gives us this logical vector. So that's what's going inside here. So we're saying false, true, false, true. That's all going inside here, right? False, true, and so on. It's all going inside here. So it's just going to actually select out only the ones where it's true. So how many trues are there? 1, 2, 3, 4. So there's only going to be, this is only going to result in 4. So this one will be in there, but this won't. This will be, and so on. So let's see what it looks like. So just the ones that were greater than 0. Kind of interesting the way that worked, though. Now, this could sort of be thought of as function composition here. So this is kind of a function in a way, because it's producing this string, and then that's going into here, or into the square brackets actually. So we could kind of think of this as also function composition. Let's try this again. First of all, let's make the vector, let's make x a little bit simpler than this one, which is all these decimal point numbers. So let's just clean it up a little bit. So it looks like this. And we could run the same thing that we just ran, this, and we only get the positive ones. Now let's try something a little bit more complicated. So this is a little bit complicated. So when we do it, we get this. Now what's happening? First of all, let's think about this symbol here. This is OR. And so, okay, so it's just, this is OR. Let's just look at this side. What's this? X is less than or equal to -2, so that means x is smaller than or equal to -2. This one says x is greater than 5, and this whole thing is a statement within the square brackets. So actually it might pay to do that statement first. This is no. let's just look at this statement. What is this going to do? It's looking at x. Hope we have the precedence right here. Let's see what happens. Yeah. So it's going back to, where's our x vector? Here it is. So we want those that are either, so this is or, so it's either less than -2 or greater than 5. So this is false. This is less than -2, so that's true. This is false. This is false. This is true, true, true. So that's what we get. False, true, false, false, true, true, true. Now we've put this inside the as an index, so to speak. So what we're selecting is the second piece and the fifth piece, sixth piece, and seventh piece, right? So let's try that again. So the second number is what? -3, and also this one, and this one, and this one. Like that. So make sure you understand that before going on. And test yourself with this one, so that now this one has, instead of or here, it has and. So what's this going to give? If this is x up here, what's this going to give? So x is greater than 40 and x is less than 100. Okay? So we can sort of select out just the elements of x that we want, because we're using as the index statements about x. Right? As the index, inside the index, we're using statements about x. Okay, here's another one. Suppose I make a vector y like this. So what is y? Y is just 1 and 4. Does this make sense, and if so, what does it mean? So stop the video and make sure you know what it's going to say, and then check it. Okay, it chose the first and fourth element, which is expected, but we use this y in here. It looks kind of mysterious. Okay, let's try this one now. This doesn't seem to make sense as an index -1. So this is strange, but what this is doing is it's taking out the first element and leaving everything else. So you need to learn that or memorize that as well. Remember, x is that, so it's taken out the first one. And you can also do something like this. So this is taking out the fourth and the sixth one. And you can make other similar arrangements. We can also do this one. So this will eliminate the first, second, and third elements. And notice that without the parentheses, this would give a completely different answer. Okay? So it doesn't like to have, it's like saying take out -1 to 3. So not to take out, sorry. It's like we have a vector from -1 up to 3. So it really doesn't know what to do, because it doesn't really like to have negatives and zeros. Or rather, I'm sorry, no, it doesn't want to have a 0 with a positive subscript. So you can have a 0 subscript here and positive subscripts in this, and it doesn't like that. Okay, now one more case here. we haven't really talked about names of elements for vectors. We've talked about factors, but those are the values are nominal. But I'm not talking about that. I'm talking about having a vector, but giving names to the values. Sounds kind of odd, but see what I mean is right now. Suppose we have a vector like this, which is supposed to give you like the pH of several different measurements. So 4.57, 7.3, 8.2, 6.3. Now, what we can do, we haven't really done this much before, but we can just give these values names. So what I mean by that is this. Now there's 1, 2, 3, 4, 5 here, and there's 1, 2, 3, 4, 5 here. So this is area 1 had a pH level of 4.5, area 2 had a pH level of 7, and so on. And these are just the what we've done is we've taken pH and we said let's assign names to each of these values. So that's just a kind of a convenient thing to do for a vector. You can assign names to them. These are not levels. The values are here. These are not the values. These are just the names of these. Okay? So you might think it's odd, but it's certainly, you can't argue that it's not convenient. Okay, to take a vector and then give each position a name. And now if we print out pH, if we had printed out pH, we would have just had the vector 4.57. I should have done that, but it's too late. No, it's not too late. Haven't assigned the names yet, have I? Okay, let's do pH. So this is just a vector now. But once I do the names, so now I'm going to change this. Now if I print out pH, it's going to print out not just the values, it will print out the values, but also associate names with each one. Okay, so it might seem strange, but you can't argue that it's not convenient to have this. Now you could accomplish the same thing like this by saying pH is, you don't need to add the name, you don't need to add names at the end. In other words, like this, after you create pH, then add the names. You can do it right away. You can say pH, and then you concatenate area 1 equals 4.5, and so on. This will do the same thing. Now if I do pH, I still get the same thing. So you can do it all in one step. Now you can use these names to index. We've been talking about indexing. We know that, for example, I could do pH. I could do pH2. Now we haven't indexed a vector that has names associated with it. So this isn't just going to give us 7.0. It's going to also tell us the name of that element as well. So you can index the vector. You can put an index into the vector and get something out just like this. But if you want, you can also use the name to get out the value. So instead of saying pH third element, you can identify it, but you need these quotes by the name of the element. Okay? Now the name doesn't affect, like if I do a calculation on this vector, the name is not part of the calculation. Okay, it's just the name of the element. So that means, like if I do pH minus 3, so I'm taking all the pHs and subtracting 3, the names don't change or anything like that. It's just the vector changes. Names are just sort of on the outside. Of course, you can also do something like this. And finally, you can have the index can be empty, and that means that all the elements are selected. Now let's see this for example. Okay, what does this do up here? Now I took just, I'm indexing just the ones area 1 and dam, and what am I doing from pH? What am I doing? I'm setting those equal to 5. So now I get this. Area 1 and dam are now equal to 5. Okay, now this one is kind of strange because there's nothing in there. So you might say, well, nothing gets set to 0. It's just the opposite. So this means set them all equal to 0. Okay, so if I do that, I ruin everything, but now they're all equal to 0. Now that's different than doing something like this. Very different than if I did this. What's the difference between this one and this one? Now, after I do that one, and I check pH, it just sets the whole vector to a single element, 0. So it doesn't fill in all the values and maintain that there are still 5. No, it just makes pH equal to the single element 0. Okay, so it's very, very different. Alright, this is halfway through this long review before we get into data mining, and I'll split it up and go on to make a new video from here.